Okay, this is example 4 in section 3.2. And as you guys can see, it's a pretty long example. It's an opportunity to bring in a lot of what we've been doing so far and apply it to a real world problem, or a word problem, we can say. So I'll just zoom in here. So it says a golf ball is struck and its height with respect to time is represented by the function h of t is equal to minus 3t squared plus 12t, where the function h of t represents height in feet and t is time in seconds. So hopefully you can picture this. We have a golf ball being struck from some spot, and it sails through the air like that. For those of you who have done physics, this is pretty much a projectile problem. So yeah, there's the golf ball traveling, and this arc, or this parabola, quadratic I should say, is represented by this function here. Alright, so what is the direction of opening? I've kind of given it away with my little drawing there, but because our a value here is a negative, so negative 3, that's less than 0, that tells us that it opens down. Hopefully you can see that anyways from just thinking about what this problem would be physically. Right? When you hit a golf ball, it doesn't sail up like that, right? So will the ball attain a maximum height or a minimum height? So it's going to hit a max, right? It's going to, technically the minimum height is wherever it's going to start or wherever it goes, depending on elevations, but it's going to reach a maximum height at the top of the arc there. And what is the maximum or minimum height? So we want to get the coordinate of the vertex here, the x-coordinate of the vertex. So that is equal to, using our negative b over 2a formula. So we have negative 12 divided by 2 times negative 3, which has given us negative 12 over negative 6, which is 2. And then we're going to go back to our equation, which will give us height, and plug in 2 here for t, and this will give us our y-coordinate of the vertex, which is our maximum height. So that is negative 3 times 2 squared, which is 4. Maybe I'll write that out. That step there. Negative 3 times 4 plus 24 is going to be, so that's negative 12 plus 12 is 12 feet. So that is our max height. Okay, so let's keep going. When does the ball reach its maximum or minimum height? Well, we just calculated that already. It's when t equals 2 seconds. Again, that's the x-coordinate of our vertex. What is the y-intercept? So our y-intercept here will be that we'll say that the golf ball starts at, we'll say that we start at a height of 0. It soars up to a maximum height up here somewhere of 12 feet, and it lands, wherever it's going to land, assuming back at 0. So our y-intercept will be 0. It doesn't tell us that it starts at 0, but we're just going to assume that, when we're as a projectile, we're starting at a reference of 0. So the golf ball starts at a height of 0 feet. So, i.e. on the ground. For this problem. And this could be, other problems we could change this. So let's create a table of values now. We're not going to use any negative x points because, where the x is time here. So we'll say it doesn't make sense to use negative time. Negative values for time. So we'll start at 0, and let's go just a couple of points, a couple of seconds, like that. So I'll rewrite our equation here just so we can see it. So you plug 0 into that, gives us 0 back. We know that 2 equals 12. If we plug 1 here, we get minus 3 plus 12 is 9. 3 will give us minus 3 times 3 squared. So we're going to get 9 there again. So it'll be, minus 3 times 9 is minus 27 plus 36. And then we'll plug in a 4 there and get 0 again. Yeah, you guys can work that out if you'd like. So we'll label some of these points. Let's start with the vertex. So it's a height of 12 at a time of 2 seconds gives us this point. At 1 second, we're at 9 feet. We know at 0 seconds, we're at 0 feet. At 3 seconds, we're at 9 feet as well. And we're back to 0 at 4. So I'll do my best to draw a smooth quadratic. Like that. So how long was the ball in the air? Well, it's back down after 4 seconds, so it's in the air for 4 seconds. Let's state our domain and range of this function. So our domain is going to be between 0 and 4 seconds. So time is less than, or 0 is less than or equal to time is less than or equal to 4. And every point, we're talking about time, every point in between can be included. So we're using real numbers. For our range, we're going from 0 up to 12. Oops. 0 up to 12. And we'll measure everything in between. So we're working with real numbers again there. And there you have it. So it's a long problem, but allows us to at least model something real, which is the real value in learning about quadratics.